Hello everyone and welcome to Medford Anywhere Learning TV. We're glad you're tuned in. We want to give a shout out to our friends at Southern Oregon PBS, KTVL, KDRV, and the Dove Network. Thank you for hosting us on your station. In the Medford School District, we have one shared vision, and that we believe that all are learning, and learning is for all. And what better place to do that than right here on Medford Anywhere Learning TV.
Oh, hi there. Hey, I'm about ready to watch a really neat old film on chemical reactions. Yeah, today's episode's really cool because it talks about exothermic versus endothermic reactions, molecules, elements, atoms. If you don't know those terms, then don't worry because on today's episode, we'll learn about all those things and plus a lot more. Are you ready? Okay, buckle up because here we go in 3, 2, 1. Hi there, welcome to another episode of Science Rewind, where I rewind the science for you. Today's topic, it's all about chemical reactions. But what is a chemical reaction? Well, to understand what a chemical reaction is, we have to understand what it's not. So what's opposite of a chemical reaction? Well, a physical reaction. For instance, if I have this piece of paper here in my pocket and I rip it, was there a chemical reaction that took place? No, it's just a physical reaction. What happened was the paper went from one whole piece to two. There was no new substance that was created. It's just the same piece of paper. What about over here to my right, this hand boiler? Well, as I look at it, I see there's blue liquid in here, and I wonder if I put it in my hand, what will happen to the blue liquid? Let's find out. Oh, the blue liquid's going up the tube, and it looks like it might actually be boiling. Well, it's not really boiling, it's just being forced up the tube because the liquid is being forced by the gases that are being heated up in this container. And as the gas heats up, it actually creates pressure and it forces the liquid upward. So if I touch the top of the hand boiler, the liquid goes back down. Well, that's not a chemical reaction. How about these two vials? I have some red food coloring in one with some water and just some plain tap water in the other. If I mix the red with the plain, what will happen? Will it be a chemical reaction? Well, let's find out. Yeah, it's not a chemical reaction, just a physical change. It went from clear to red. There is no new substance being created, so it's a physical reaction. Well, if this is a physical reaction or change, what about these two containers over here? This looks very promising. They look kind of cloudy. They look kind of the same, but what if I was to pour one container into the other? Would there be a change, like a chemical reaction? Let's find out. I'll just mix it here a couple times. So far, nothing's happening. It's just kind of the same color, kind of a cloudy liquid. But in one of the containers, I had vitamin C and iodine. Now, iodine is a very dark color, and you couldn't see it because, well, the vitamin C gobbled it all up. It kind of like made it disappear. In the other container, I had starch and hydrogen peroxide. Well, starch is really good at revealing the iodine because it gobbles up the vitamin C. And I think if you watch right now, you might just see a little bit of magic. Well, not magic, it's science. What happened was the starch was present, and so it actually made the vitamin C show or reveal the iodine because it gobbled up the vitamin C. What was left? Iodine. So that was a great example of a chemical reaction. This is actually called the iodine clock reaction. Well, look it up. So how do we know about chemical reactions if we don't understand about the chemicals that are being used to react? Well, chemists like to use a chart they call the periodic table. It's behind me here. They can look at those elements on that table and they can see how to put them together or break them apart to form new molecules. And in doing so, we get chemical reactions. Take a look.
All matter in the universe is made up of these building blocks, called elements. So far, scientists have discovered or made 118 elements and arranged them on the periodic table, which includes solids, liquids, and gases, and both metal and non-metal elements. Each element is made up of a unique type of atom. Atoms are extremely small, but they are made of even tinier particles called protons, electrons, and neutrons. Electrons exist in the outer shell of an atom, while the protons and neutrons are together in its center. The number of protons an atom has determines what element it is. Hydrogen has 1 proton, helium has 2, carbon has 6, oxygen has 8, and so on. Atoms can come together and form bonds to create molecules. Because there are so many different ways to arrange atoms, trillions of different molecules can be made from just a few elements. For example, water is made up of 1 oxygen and 2 hydrogen atoms bonded together. When molecules interact with each other so that bonds between molecules are broken and new molecules are formed, then a chemical reaction has taken place.
Hey guys, I'm Mr. Holst. I am a friend of Mr. Franklin's and a fellow science teacher with him, and we're here to explore some chemistry together. He's already talked to you about what is the difference between a chemical reaction and a physical change, and there's a big difference. I'm here to help you right now identify 5 clues. There's 5 ways that you can tell a chemical reaction is taking place. So here we go. Here's the first one. If you see 2 things being mixed together and you see bubbles, haha, there you go. That is a chemical reaction. Watch. I'm going to take some hydrochloric acid right here, and I'm going to mix that together with some baking soda. And when I do, these 2 reactions, this liquid and this solid right here, are going to make something different that we didn't have before. Are you ready? Watch. What do those bubbles represent? Well, when this was taken apart, a gas was formed, and all those bubbles were the gas that was bubbling out. We didn't have a gas to start with. We had a liquid and we had a solid, and it made a gas. So there you go. There's your first clue. When you see bubbles, that means a gas is being formed.
You're exploring chemistry with hydrochloric acid and baking soda. In the reaction between baking soda and hydrochloric acid, these bonds in between are broken. Hey, easy does it, Mr. Scientist. Those atoms are easy to break here, but not so much on the molecular level. The byproducts are salt, NaCl, water, H2O, and carbon dioxide, CO2.
Another clue that a chemical reaction is taking place is when we get a color change, but a color change that we didn't expect. When Mr. Franklin put the food coloring in the water, we expected it to change color. But here I have some lead nitrate, which is clear in color, and also some potassium iodide. When I combine them in this beaker, you'll see what happens. So the question is, why did we get such a bright yellow color from two clear liquids? Obviously, it was a chemical reaction. An interesting fact about this reaction in particular is that we used to use this bright yellow pigment as paint for houses before we realized that the lead was toxic in it.
So, previously, we saw David mix two clear chemicals together, and that made a yellow liquid. Here, I took David's yellow liquid and poured it into filter paper. Let me show you what happened. Here, as you can see, there's a solid on the bottom. And when David performed his experiment, he actually made two different substances. This yellow solid, which is lead iodide, and a clear liquid, potassium nitrate. So, David's sign was that a color change had occurred, but we have another sign of a chemical reaction here. A precipitate formed. You can also see it in the filter paper here. And that's just that solid stuff that came out of the solution. So, we already have covered 3 clues that a chemical reaction has occurred. What do you think the other 2 clues will be?
Now we're looking for a 4th sign that a chemical reaction took place. I have in my test tube some plain tap water, and currently the temperature is reading 20 degrees Celsius. I also have 2 powders. I have citric acid and baking soda. So I'll be putting both powders of equal amounts into the test tube, and we'll look to see of 2 different signs happening during this experiment that a chemical reaction has taken place. Are you ready? Let's begin. So I'm going to pull the probe out of the water, and I'm going to first put in some citric acid, about half a teaspoon. Carefully putting it in my funnel as the powder goes down. And I'm going to do a little bit of tapping to make sure the powder goes into the test tube. And it just takes a little bit of probing here. There we go. And I'll stir that up so it's evenly mixed. And that's about all the powder right there. And you can see it dissolving into the water. Looks a little milky. Now I'm going to be adding some baking soda. And I want you to look for a reaction. Are you ready? Here we go. So same amount, about half a teaspoon. And watch what happens. Wow, that is pretty incredible. Already it's bubbling. Carbon dioxide, I believe, is being formed right now. And as we look at the graph, as I collect the temperature, it's now going down pretty rapidly. It went down from 20 degrees, and it's going down to 10, and down to 9 degrees Celsius, and it's continuing to drop. So what just happened here? Well, this is a great example of an endothermic reaction. What happened was the reaction had to take energy from the water in the test tube in order for the reaction to take place. It had to transfer that energy or absorb it, and then we had an endothermic reaction. This is incredible. Well, the bubbles have almost stopped bubbling, and ooh, that test tube is really cold. I can feel definitely it's gotten colder. This is an amazing example of a chemical reaction. Now we're going to do another example where the temperature is going to change, and we're using hydrochloric acid in a test tube and also some magnesium. Now, magnesium is a metal that you can find listed on the periodic table, and it's a metal. So let's find out what happens if I put magnesium into hydrochloric acid. And right now my temperature is reading about 19 degrees Celsius. So here we go. And there's some bubbling happening, and gas is being, you can see that gas is being given off there as I record my temperature. boy, the temperature is really increasing. It went from 19 degrees, now it's up to 35 degrees, going up to 40 degrees. Well, that gas, you can really smell that gas from here. It's still going up to 44 degrees, 50 degrees. It's really, really getting warmer. As you can see on the chart behind me here, that the graph is still climbing. So what's happening? Well, there's a temperature change that's going on right now. What happened was that the chlorine and the hydrogen, they broke old bonds, and now the magnesium and the chlorine are now bonding together, and that's actually creating energy. But there was energy that was left over after those bonds were broke and put back together. So now we have extra energy, which means that we have an increase in temperature. And we're still peaking about 55 degrees. Pretty incredible, huh? And if I touch the test tube, yeah, it's pretty warm. I can feel that right now. That's a pretty warm test tube right there. Well, there you have it. This is a great example of an exothermic reaction, and energy was left over and it created a higher temperature.
All right, time for your test. Got a candle and this lighter here, and when I light this, now you have to decide chemical reaction or physical change. Well, you might say, well, the candle's melting, physical change. How about this flame here? What do you think? I hope you said chemical reaction, because anytime you see flames, it's a chemical reaction. That's our fifth and final clue of a chemical reaction. So if you're keeping track, we've got bubbles. Anytime you see bubbles, it's a chemical reaction. Anytime you see a color change you didn't expect, anytime you see a precipitate, a solid forming, when two liquids are mixed, it's a chemical reaction. Anytime you see a temperature change is a chemical reaction, and last, flames. So let's see if we can get a more exciting flame. In this bottle here, in this flask, earlier today I put some liquid. This liquid is hexane, and it has a pretty high evaporation rate. So I believe that it's been evaporating in here and filling this bottle with the gas. So we had to change of state. And I know that you know by now that's not a chemical reaction. So what I'm going to do is I'm going to try to pour this gas down this ramp right here. I have a metal ramp to this candle. When it reaches the candle, we'll see something interesting happen. All right, are you ready? Here we go. All right, did you see that? Let's do it one more time. Yeah, as you can tell, this gas is flammable. Voila, there we go. Did you notice something interesting about the gas in here? I could pour it. If I can pour it, that means it's heavier, it's denser than the air. Just like helium is less dense and floats, or the hydrogen balloon floated, this hexane gas, you can pour down the ramp right here. And of course, when it reaches the candle, it's flammable. So it followed the vapor trail back up here. So, are you guys ready for a few more flame demonstrations? Here we go.
Hey, Maddie.
Oh, hi, I didn't see you there.
Yeah, what are you doing with the candle?
Well, I'm studying it. Isn't it fascinating?
Yes, it's very fascinating. But what are you hoping to show the viewers with the candle?
Well, you know today's episode is all about chemical reactions.
That's right. There's 5 signs that a chemical reaction took place, and I think that if you see a flame, that's one of the 5 signs.
Yes, but this also shows the combustion triangle. Ever heard of the combustion triangle?
The combustion triangle.
Yeah.
Yes, but I forgot.
Oh, okay, well, I'll tell you.
Okay.
It consists of three things, which is oxygen, heat, and fuel. Without these three things, the flame cannot sustain itself.
Okay, so if we go back to the candle model, we have oxygen, which is around the candle. That's a no-brainer. That's the air. The heat would be the lighter, and the fuel would be the wax.
That's right.
Okay.
I'm going to show the audience what happens if I blow out this candle and relight it, but I'm not going to relight the wick.
Wait a minute. That's scientifically impossible because the wick is the fuel. So if you don't light the wick, you don't have the fuel part of the triangle and it won't light.
Well, I think I can prove you scientifically wrong.
All right,
You
let's
ready?
see it. Wow, that was pretty impressive.
Did you see that?
Yes, is that magic?
No, it's not magic. It's just science. It's really cool though. Do you want me to show you again?
Yeah. So you lit the smoke that was above the candle and it ignited the wick.
That's right. Well, it's not the smoke itself, but the wax that's in the candle. When the candle was burning before, the wax began to vaporize and went up with the smoke in the air.
Okay.
So when I brought the igniter to the smoke and lit the candle, it traveled back to the candle where there was more fuel because it already had fuel in the air, but it wanted more.
Okay, so there's wax particles in the smoke that traveled back down to the wick and it made it ignite again.
That's correct.
That's great. Well, try this at home, but be very careful. Make sure there's a parent or parents with you because it is open flame and it could cause some problems. So don't touch the flame and don't knock the candle over. But have fun, try it a few times and see if you can make your candle relight by just relighting the smoke.
So this is a great do-it-yourself experiment based off of elephant's toothpaste, but this is an experiment you can do at home. So for this experiment, you'll need some instant yeast, some 3% hydrogen peroxide, and food coloring to make your own elephant's toothpaste colors. All right, so to prepare the yeast, I mix some hot water, about 2 or 3 ounces, with 2 spoonfuls of yeast. And I just got some hot water as hot as you can get and mixed it with the yeast till it was a concentrated solution. And then here I have 150 milliliters of hydrogen peroxide. So I'm going to pour the hydrogen peroxide in here. And that was the same thing we used with the elephant's toothpaste, except this is less concentrated. It's 3% instead of 30%. And then I'm going to use food coloring. All right, a little bit of green there. You'll need 1 drop around each side. And do some blue food coloring too. All right. Okay, and now I'll put in our yeast. Yeast in this case is our catalyst. So I'm gonna do 4 scoops of yeast. All right, and you should start to see a reaction happening. All right. So, you see if you can spot one of the signs of a chemical reaction here. What's happening? It's bubbling, right? So, as we said before, that's one of the signs of a chemical reaction. Now, this reaction is actually producing oxygen. And that's what happened before with the elephant's toothpaste. The hydrogen peroxide decomposes into oxygen. And the yeast is a catalyst in this reaction, so it speeds up the reaction, but it's not actually involved in the reaction itself. It stays the same throughout the reaction. All right. That looks pretty fun. So this is a great do-it-yourself reaction you can do at home with yeast and hydrogen peroxide and some food coloring.
Now, I'm going to show you how to do a fun DIY experiment here that you can try at home. we've discussed the combustion triangle, and so this experiment is going to demonstrate what happens when one of the three parts of the combustion triangle is not there. Now we have baking soda and vinegar. I'm going to put in 1 tablespoon of baking soda into this container here. I'm also going to pour 50 milliliters of vinegar in as well. Now you'll notice some bubbling and fizzing taking place. Now remember, this is one of the signs that a chemical reaction is happening. I'm going to stir this up until all the baking soda dissolves. Do you know what gas I'm producing here with the vinegar and baking soda? Well, if you said carbon dioxide, you'd be correct. So in here we have carbon dioxide, but in this container we have oxygen. Oxygen is all around us in the room and it's going to take up space. So I'm going to light this candle here. Magic science hand, please. Thank you. I'm going to put this in the container full of oxygen and we'll see what happens. So the candle is staying lit. That's because that is one of the three things that a fire needs to stay lit. Now I'm going to put it into this container here with the carbon dioxide. Let's see what happens. So you notice it went out. Well, if there's no oxygen in there, it will go out. And because carbon dioxide is a heavier gas, it displaced all the oxygen, and so there is no more left in there, so the flame could not continue to burn. Now I'm going to try something interesting. I'm going to see if I can pour the carbon dioxide into the container of oxygen, and then when there's no more carbon dioxide in here, there should be oxygen instead. Let's see what happens. Now you notice I'm pouring this here without any of the liquid going in there. It's just the gas. Even though we can't see it, I'm going to prove that there is carbon dioxide in that container. Magic science hand, please. Thank you. Now I'm going to put it in this container, and if there is carbon dioxide in here, it should go out. Let's find out. So we know there is carbon dioxide in there because the candle did go out. Now we're going to try the other container. Magic science hand, please. Thank you. Now I'm going to place it into this container, and if this one stays lit, we know there's no more carbon dioxide in there. Let's find out. So it's still lit. That means the oxygen has replaced the carbon dioxide that's in there. So we know carbon dioxide is great for extinguishing fires. In fact, that's what they put in fire extinguishers.
Well, that wraps up another episode of Science Rewind. It was all about chemical reactions. And if you want to contact me with a science question or comment, please email me at the address below, and I will get back to you and hopefully answer your question on the next episode. In fact, we have one from a viewer. Her name is, Maria Vasquez. She's an 8th grader, and she writes, "Dear Mr. Franklin, I noticed that you're bald. Did you lose your hair in a chemical reaction?" Very, very funny, Maria. No, I did not. No, my grandfather was bald, and so was his grandfather, and well, hence, so am I. All right, well, as always, stay healthy, stay learning, and we'll catch you next time on Science Rewind. But you have something else to show us, don't you?
Yep, I have something really cool.
Wait for this one. This will be explosive.
That was creepy.
Thanks for tuning in to Medford Anywhere Learning TV. Medford School District is a place where all are learning, and learning is for all.